Thank you for joining this lesson. We're going to continue with the revision of the Kcse examination 2022 exam, Mathematics Paper 1. Number 21, a question from statistics. We are told that the amount of money in Kenya shillings spent on airtime by a group of 30 people in a period of an hour was recorded as shown below. So we have the number of the shillings here. The cost of airtime spent by a group of 30 people in an hour. Complete the frequency distribution table below. So we have a frequency distribution table here. So that we may fix the frequencies of the respective classes, allow me to come up with a small table here of the classes, then a tallying column. The classes are 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. We have from 20 to 24, then from 25 to 29, then from 30 to 34, 35 to 44, then we have 45 to 59. So now we can allocate each amount of airtime to the respective class. 27 is lying here, there is 1. 20 is here. 21, this class. 24, this class. 22, this class. 25, this class. 42 lies in this class. 34 lies in this class. 55 lies in this class. 26 is found here. Then we have 30 is found here. 39 should be here. 35, this class. 46 is in this class. 32, this class. 21 in the first class here, so write it like that. 38 should be found in this class. 34 in this class. 31 this class. 37 this class. 27 this class. 29 this class. 32 this class. 56 the last class here. 33 is found in this class. 44 this class. 25 this class. 31 this class. 28 is in this class. 30 finally is in this class. Therefore in this class I can see 5 plus 4, which is giving us 9. This is 5 plus 2 giving us 7. This is a 5. This is a 5 plus 1 giving us 6. This is only 3. So when we add up, this is 12, 21, 21 plus 6, we're going to get a 27, then 30. So we have distributed the marks well. So we can start with 5, is the frequency. 7, 9, 6, 3. The next class, the next question that is, we are told on the grid below, draw a histogram to represent the data. Draw a histogram to represent the data. One thing we should know about a histogram is that we have different types of histogram. As you can see here, our data is not in uniform classes. There are larger classes than others. For instance, the class width here is 10. The class width here is more than 10, 15 actually. So the class width here is 5, 5, 5. So now that we have different class width, we will not plot frequencies against class boundaries. Instead, we're going to come up with what we call the frequency density, which is usually calculated by the class width, frequency, divided by class width. So we'll be taking every frequency and we divide with the class length. For instance, we'll start with 5 and we divide 5 with the class length, which is 5. So we're getting 1 here. The next one, we will divide 7 with 5. 7 with a class length of 5. We get 1.4. In the next, we will divide 9 with 5. We get 1.8. In the next class, we will divide 6 with 10. 6 with 10, we get 0.6. Finally, we're going to have, remember, for us to get class length, we are taking the lower class boundary, which is 44.5, and we subtract it from the upper class boundary, 59.5. 59.5 minus 44.5. This is a class length of 15. Therefore, we take 3 divided by 15, and this will give us 0.2. 0.2. So these are frequency densities. So in a class, in classes which are not uniform, histogram is a function of frequency density against the class boundaries, the upper class boundaries. Therefore, I'm going to come up with the axis whereby I need frequency density to be on this axis. This is a frequency density. Remember to subscribe to this channel and to share the link as we continue working together. Then on the horizontal axis, I'm going to have my class boundaries, or rather the airtimes now. The airtime in shillings. So we're going to have our upper class boundaries here. Class boundaries. Class boundaries. So now, let me get a good scale. A good scale. We can use a scale of 1 unit in the vertical axis to represent 0.2, so that when I start from 0 here, I'll go to 0.2, 0.4, then 0.6, 0.8, 1.0, 1.2, 1.4. This will be 1.6, 1.8, yeah, 2.0. I think we are beyond even the greatest frequency density. So frequency density's axis is already sorted. It's already sorted. We can now go to the other side, whereby we need to plot the boundaries. If the boundary, the least boundary is starting from 19.5 and the greatest is 59.9. So one thing we should know is that when we start with an axis of 0 and we use intervals of 5, there is a margin of the horizontal axis which will be idle. Therefore, we can break the axis and we begin with the least class boundary, which is 19.5. Then we use intervals of 5. So 19.5 can be our first interval, 19.5. Then we go to, when we add 5, we go to 24.5. We add 5 to 29.5, 34.5, 39.5, then 44.5, 49.5. This should be 54.5, and finally 59.5, which is the greatest upper boundary. So now we can plot upper boundaries against frequency densities against upper boundaries. So we'll start with 24.5 against 1. So 24.5 against 1 is here. That is the first class. It starts from here to here, and the frequency density is 1. The other one begins now from 24.5 up to 24.5 up to 29.5, and the height is 1.4. The height is 1.4. Therefore, up to here and to 1.4. Yes, that is the point. The other one is flowing from 29.5 to 34.5. So to 34.5, and the height is 1.8. 1.8. The other one is from 34.5 running up to 44.5. So up to 44.5, this is the class from 34.5 to 44.5, and the class is having a height of 0.6. 0.6 is here. Finally, we have up to 59.5 with a 0.2. So up to here with a 0.2 as the height, this one. Therefore, now we can come up with the bars to represent the classes. The first class from here to here with a height of 1.4. So this is the first class. The next one is beginning there with a height of 1.4, but yeah, the upper boundary is there. So this is the next. That is the next. Then the other one now is having a bigger height of 1.8. 1.8. So up to here. Yeah, this is the other class now. That is the class. The next one is having a bigger class length, a bigger class interval up to this point with a height of 0.6. A height of 0.6 like that. That is the other class. Then finally, we will have the broadest class with a height of 0.2. So this is the final class. So these are the classes represented in these bars. Represented in these bars. So that is how we plot a histogram when the class boundaries are not uniform. So this is the histogram for the ununiform